Okay, we're moving on to 11.3, okay, which is on page 298, and it's called using trig identities. Okay, so what's going to happen now is we're going to be using trig identities to integrate the questions that we are given. Okay, so the first one is find tan squared x dx. Okay, now if I go back to my list, I can't see tan squared. Okay, so I don't know the integral for tan squared. So what do I know? What identity do I know that is going to help me here? So you've learned that from you learned that in book 1 actually, when you learned trigonometry and when you learned trig identities, that the identity that we can use here, actually not in book 1, you learned this in book 2 in chapter 7, I believe, chapter 6 and 7, yeah, chapter 6. You learned this identity in chapter 6 of book 2, and the identity is sec squared x is identical to 1 plus tan squared x. Okay, so this identity is going to help us to integrate tan squared x. So tan squared x is equal to sec squared x minus 1, and I'm going to substitute that in there. Okay, and now go back to my list, and I know the integral for sec squared, which is tan x. So this integrates to tan x, and 1 integrates to x, and I put my constant there. Okay, right, so we've used the identity to help us to integrate tan squared x, and our final answer is tan x minus x plus c. Don't forget that. Okay, so this was the identity. Just make it really clear that you're using this identity. Next example. Okay, it's on page 299, and the next example says show that pi over 8, pi over 12, and we have sine squared x dx, and we want to show that it's equal to pi by 48 plus 1 minus root 2 over 8. Okay, right, now I've got sine squared x, and I don't know the integral for that from my list. Okay, and I can't just integrate it using my chain rule, so I can't make my substitution sine x and then have u squared. It's just not going to work. Okay, so what we need is we need to find an identity that can help us here. Alright, so the identity that we use to integrate sine squared is always cos 2x double angle formula, and that is 1 minus 2 sine squared x. I'm going to now rearrange this, and I will get 2 sine squared x equals 1 minus cos 2x, and then sine squared x is equal to 1 minus cos 2x over 2. So this is something that I can integrate. So I'm going to substitute that in there. I will take the half out. Okay, so I'm going to take the half out of it, and I'm going to have 1 minus cos 2x, and I will integrate this. Okay, I will substitute my limits in as well. Okay, and then hopefully I'm going to come down to this answer that is on the right hand side. Alright, so if I integrate 1, I get x. If I integrate cos 2x, I am going to get 1 over 2 sine 2x. Okay, and I know I'm going to get that because basically when I was using reverse chain rule, okay, if I go back to my previous examples, and if you look at cos 2x plus 3, what happens is, imagine if I didn't have the plus 3, I would still have the half on the outside. So basically what happens is if I differentiate 2x plus 3, I get 2. I divide that with the integral of cos u. It's opposite to what happens in differentiation, where you multiply by it. Okay. Right, so cos 2x then integrates to half sine 2x, and I'm now going to plug in my limits. And I'm going to show you how you can do this on your calculator. Hopefully we will get an exact value. We might not. Right, so... Okay. Right. Now there is a way of, as you know, of doing this on your calculator. Oh, hold on a minute. I have already integrated this. Let's try anyway. So if I put in the question from the beginning, bracket, and I have pi by 12, and I have pi by 8, and if I press equals, will I get an exact value? Hopefully. No, I don't. So this is the reason why your calculator is not going to work here. Actually, divide by 2. And then, but what you can do with this is, if you do get an answer in decimal, you can convert this to decimal and then check whether you're going to get the right answer. Okay, so if we jot it down, 0.01367, and if I convert this to decimal, I mean, it can be useful in the exam to check your answer. Even if you can't get an exact value with the calculator, you're going to do it by hand anyway. So, yeah. So see, you get the same answer as what you jotted down before. Right, now let's just do it by hand. We're going to have to do it by hand because they want an exact value. So, I have half. I'm going to leave that out. And I will have pi by 8 minus half sine 2 times pi by 8. I'm going to leave this half out. Minus pi by 12 minus half sine 2 pi by 12. Okay? And I'm now going to try and simplify this. So I've got the half out. Not going to touch that. I've got pi by 8 minus half sine pi by 4 minus pi by 12 plus half sine pi by 6. Okay, so pi by 8 minus pi by 12, what is that going to give me? That gives me pi by 24. Okay, so I've dealt with these. Now I've got sine pi by 4. So sine pi by 4, root 2 over 2. So I've got minus half times root 2 over 2 plus half sine pi by 6 is just a half. Okay, and then you have just simplify these two answers. So I've got a quarter minus root 2 over 4. Okay, so this gives me pi by 24 plus 1 minus root 2 over 4. And then if I multiply everything by a half, I'm going to get pi by 48 plus 1 minus root 2 over 8. And that was what they wanted me to show that. Okay, and I have. Right, now I've just got 2 more examples for this, and I'm going to continue that in the next video. Okay.